All right, so today we're going to start by just reviewing how do we write the electron configuration for oxygen. So first, you just need to find oxygen on the periodic table. Okay. So find oxygen. What is the atomic number for oxygen? Okay, oxygen's number 8. So I'm just going to outline it in blue. Okay. And so we're always going to start at the top left. We'll always start at hydrogen, and we're just going to read through the periodic table until we get to the element that we're interested in. Okay. So what do we always start with? Okay, so it's always 1s2. And then where do you go after 1s2? Okay, 2s, and we're past both those boxes, so 2s2. Where do you go after 2s? Okay, 2p, and then we're going to count boxes till we get to oxygen. So it's 1, 2, 3, 4. All right. So oxygen stops at 2p4. All right, any questions just with like the electron configurations? Okay, next I want to do an orbital diagram with you all. I showed you one on the slides on Friday, but it didn't make you draw one, so I want you to draw one with me. So for the orbital diagram, we're just taking this electron configuration and we're just like basically giving it like a nice visual. Okay, so we draw one orbital for that 1s. So one box for 1s, because how many orbitals does the s subshell have? Just one. Okay, one orbital is one box. And how many electrons are in 1s? 2. Okay, this little 2 is 2 electrons. When we draw electrons, we use arrows. One arrow points up, one arrow points down. And you can do like little half arrows to save yourself some time. Okay. All right. Then 2s. 2s has a little bit more energy, so we draw it just a little bit higher up. Okay. How many electrons are in the 2s? Okay, 2. So again, 2 arrows. One arrow points up, one points down. All right, next is 2p. How many p orbitals are there?
4.
Close.
Ooh.
Close. In between? 3. Okay, so because there's 3 p orbitals, you have to have 3 boxes. Okay, how many electrons are in the 2p? There's going to be 4, so we're going to draw 4 arrows. Watch how I draw the arrows, okay? Follow this like filling pattern. So when we fill in the arrows, it's 1 per box at first, and they always point in the same direction, okay? And this is that same analogy of would you rather share a bedroom with your sibling, or would you rather take your own room? Your own room. So when you start drawing these 4 electrons in, 1 per orbital, then if you have more to fill, then you go back and start doubling them up. Okay, so this is the orbital diagram for oxygen. The strength of the orbital diagram is it lets you see where the electrons are in the orbital, especially it lets you see if electrons are paired or unpaired. They want to be paired. So 2 in an orbital or 2 in a box is stable, meaning they're not going to want to react. If you have unpaired electrons, that means that they're going to want to react. They want to get extra electrons to fill that shell. Okay. So how many unpaired electrons does oxygen have? 2. Okay. So that's the whole point of the orbital diagram. It's like this nice visual if electrons are paired or unpaired. Okay, I want to do one more practice. This time we're going to do selenium, and then we'll also practice the shortcut. So first, find selenium on the periodic table. What's the atomic number for selenium? Okay, SE, and what's that number?
34.
34. Okay, so again, to get a selenium's electron configuration, we're going to start at the top, and we're just going to like read through the periodic table till we make it to selenium. All right, so what are we going to start with? Okay, selenium, we start right here. What is this? Okay, 1s, and we're past both of them, so 1s2. Okay, then where do we go? Okay, 2s2. Okay, then what? What's this section? Okay, 2p, and we're past all 6 of them. So I'm going to write 2p6. Okay. Where do you go after 2p?
3s.
Okay, 3s. We're past both of those, so 3s2. Then what?
3p.
3p. Okay, so 3p6. Where do you go after 3p?
4s.
Okay, 4s2. Where do you go after 4s? Okay, 3D. How many boxes are in 3D? Okay, so it's past all 10 of those. What comes after 3D? Okay, 4p, and then you just count how far over you are. So 1, 2, 3, 4. 4p4. Okay. Do you all agree with that?
Yeah.
Okay. Now we're still in like the top half of the periodic table. So can some of these electron configurations become really long? Okay. Also, are you starting to notice how repetitive they can be?
Yeah.
Okay, so Friday, I introduced the shortcut, which is called noble gas notation. I think we got cut off a little bit though. So I want to do a practice, like a shortcut one with you. You might see it as noble gas notation. You might see it as like the shortcut or the abbreviated version, okay? What column of the periodic table are noble gases? Okay, the farthest on the right. So these are the noble gases. So you find the noble gas that comes right before the element we're interested in. Okay, so which one comes before selenium? Okay, argon. So we're going to put argon in brackets. And by putting argon in brackets, that's replacing argon's configuration. So now we don't have to write the 1s2, 2s2, 2p6, 3s2, 3p6. So we just start right after argon. Okay, so what comes after argon? Okay, 4s2, 3d10, 4p4. Good. When you hear the word valence electrons, what do you think of? Okay, the outermost shell. So I just want to teach you, how do we know what the valence electrons are when we're looking at an electron configuration? Okay, they're the electrons with the highest shell number. So if you want to write this down, you can. And then I'm just going to copy the previous electron configuration so I can just show you what that would look like. Okay, so when we're looking at electron configurations and we want to know the valence electrons, they're the ones with the highest shell number. Okay, the shell number is the coefficient. Okay, so like these big numbers that come before the letters. Okay, so if we look at this, we have 4s2, 3d10, 4p4. What's the highest shell number that you see? Okay, 4, and it shows up twice, the 4s and the 4p. Okay, so those are the valence electrons. And then the superscript are the actual electrons. So how many valence electrons does selenium have? 6. Okay, so these are the valence electrons. So selenium has 6. Okay. I also just want to show you a shortcut for representative elements. The first column of the periodic table has 1 valence electron. The second column has 2 valence electrons. Then we're going to skip transition metals and jump all the way over to where boron is. Those have 3 valence electrons. And then it just goes in order. So 4, 5, 6, 7, and 8. Okay. So if you label your columns of the periodic table, those tell you the number of valence electrons. And then that's how you can check your work, though. So we figured out that selenium has 6. Is selenium in the same column that should have 6? Okay. So you can cross-check your work. Transition metals, they're not as nicely fit because we have electrons in that d orbital, and it's not as simple. But if we look at representative elements, they match the column of the periodic table. But you also find them by looking at the highest shell number. Okay. You okay there? Okay.